Welcome back to another YouTube Tuesday. My name is Derek, and today we're going to check in on Jesse Cruz with his YouTube channel, VCC Board Repairs, and see what he's been up to, as he always puts out content that's extremely useful, and he does it in a very clean fashion. Looking at his most recent video, it's less than 7 minutes long, titled iPad 10 Flashing Apple Logo Fixed Under 10 Minutes. How to Diagnose Bad Battery. Let's watch it together. I'm going to give some commentary on some of my thoughts and feedback, so let's get started.
This is an iPad 10 that might be having motherboard issues. Another repair shop replaced the screen on it, and then they started seeing the Apple logo flash on and off, and we're gonna go through the process of repairing it. I believe it might be a backlight, so make sure you guys join us for the full video so you can see what it takes to repair this type of issue. Now, if you need your iPad repaired, we do offer a mail-in service for anyone in the US. Reach out to me through my website and I can send you a quote. So let's go ahead and get started with this video. First important step to repairing an iPad is first understanding what is the issue. So I'm gonna go ahead and plug this into the charger. We see 5 volts, and then we get some current draw. Oh, look at that. A quick flash of the Apple logo, and then it went blank. Also, I'm noticing the current is not going up to 2 amps. It seems to be climbing up, and then it hits a certain point, and then it drops back down to 0. You can see that flash of the Apple logo. So that's pretty interesting. Let's go ahead and open this up and see what's going on. Now, iPad 10.
Either the battery that's in there is bad, the battery itself is so dead that it's not taking a charge, or one of the pins under the battery connector was damaged with when whoever replaced this battery pried under the battery connector and bent one of the data pins. If one of those pins isn't making contact, or even one of the main positive and negative terminals aren't making contact, you're going to get an issue like that where you get a flash of an Apple logo. It's probably not a backlight because you're still getting some backlight with the Apple logo. You can actually see it. Sometimes that's indicative of a backlight issue, but bet you what it is going to be one of those 3 things. Let's see what he finds.
It has a digitizer separate from the LCD, so you got to be careful with that. Make sure you don't damage either one of those parts. All right, here's the LCD. Now the screen itself is not glued down. Okay, let me get the battery screw out. Now, because this iPad has been opened before, it's very easy to tear down. Let me unplug all the flexes from the screen. Now keep in mind, iPad 10 does have 3 flex cables on here. All right, here we go. So keep in mind, there's 2 digitizer and then 1 microphone, I believe. So always keep that in mind. Let's go ahead and lay this down like this so we can protect the LCD from any damage. So let's inspect the motherboard itself. Now we are potentially having backlight issues, so let's peel this up and see if there's any tool damage, which looks clean. I don't see.
Typically, if there's going to be an issue, you actually see it through the sticker. The sticker will have a little like hole in it, a poke in it, a burnt hole in it, if there's going to be a backlight issue. So, but you definitely want to check to see if someone's accidentally knocked off any components.
See any obvious damaged components or blown components. Also check for long screw damage. Check for any kind of tool damage somewhere around here. This all looks pretty clean. This was just a digitizer replacement, so just the glass. So now it's having that weird issue. So my next step, because it's having a quick boot loop kind of flashing logo, what I'm gonna do is I'm gonna check the battery itself, see if it has any voltage. So first thing I do is slide a guitar pick to the side of the battery connector. That way we don't slide anything directly under the battery connector, but off to the side. This will create the gap that will disconnect the battery from the board. If we don't.
And there's a reason why he's saying do it off to the side of the battery connector. Like I explained, if you do it under the battery connector, you could potentially damage one of the pins. For example, if you look here, you've got the negative and the positive pads, and then you've got these 3 data lines. And the negative and positive pads are harder to bend because they're larger, but the little pins that connect to the other 3, they're really small, and you can bend them, you can kind of jam them up inside the connector, You can break them off. I've seen all sorts of issues there. And what you'll get is if the battery has charge, the device will turn on, but it won't actually charge when you plug it in. And a bunch of other symptoms that are battery power related, especially if you have a completely dead battery or a mostly dead battery. It's going to be, you won't be able to get it to turn on or charge. But if the battery is sat for an extended period of time in somebody's shop or on the shelf from a vendor, there's the possibility that it's beyond the ability of the iPad itself to bring it back into a charging position. And so in that case, if you've watched a couple weeks back, I made a video kind of demonstrating how to jumpstart a battery. I wonder if he's going to go down that route, at least just to test the battery, because that's what I would do.
You don't physically have to block the connection, we just have to separate the connection. So now that we have it separated, if you look closely, there's two large pins on the battery. They're contact based. So we got to measure those, not the small ones, but the big ones, to see the battery voltage. So set my multimeter into volts mode, and we're going to just probe the two big pins. Look at that, 0 volts. So 0 point something. This should be at least 3 volts or higher. So the battery has gone flat. So that's one issue. So if we pull up the board view of this iPad, if we look at the battery connector, we can see that the terminal has these pins. So there's a gray pin and then a red pin. Well, it's red because I clicked on it, but yellow. So basically this is going to be the positive, this is the negative. The small ones are going to be data lines. Those don't matter right now. So the goal is we're going to boost up this battery. So just like when your car battery dies and you got to attach jumper cables to charge your battery from another car's battery, that's kind of what we're going to do here. So we're going to inject voltage into this battery and bring up the voltage so that the iPad actually does not boot loop due to a dead battery. And one way to do that is with our power supply. So right now you can see it is set to 4.2 volts and 3 amps. If I short these together, we get that 3 amp draw. That means we have live voltage. And if you remember earlier, the left side was ground, the right side is positive. And then there you have it. We have 0.6 amps being injected into the battery. That is basically going to charge up the battery to some degree. And this is essentially how a battery charges. There's current flowing into it. So let's give it a few seconds to charge up and then we'll measure the voltage again.
So I like his analogy with jump starting the cars. You're basically brute forcing power into the battery versus allowing the power to flow through the charge port to the charging IC, allowing those circuits to basically clean up the current and force the battery to charge. You're bypassing all of that. If you set your power supply to the right amount, you're basically injecting the correct voltage so that you don't overdo it. And depending on how long you've left the power supply connected to the terminals will depend on how much the percentage goes up. And really all you need to do is get it past 1% when it's a fully dead battery. As soon as you get past the 1% mark, devices shouldn't have any issues popping it further than that. The longer you leave it, the higher the percentage will go. But also because you're injecting voltage, the hotter the battery will get. So you don't want to, this isn't the way to charge a battery like for a long period of time. This is something that you do for 30 seconds, a minute. This isn't something that you do like a lot. So very useful knowledge to have though, because you can basically do this on any device, an iPhone, an Apple Watch battery, any electronic device, and even other batteries in general.
All right, so I gave it maybe like 30 seconds or so. And then if we measure it now, there you go, 3.751 volts. That means the battery now has a charge. So let's test again to see what the behavior is. So my next step would be to just plug in the LCD and the battery screw so that we can do some quick testing to see if the device is fixed. So what I'm gonna do is just plug this back in and then let's monitor the current. Oh, look at that, 15 volts, and we got Apple logo, and we have almost 2 amps. Could it be that that was as simple as just a dead battery? I thought it was a backlight. I've seen a lot of iPad 10s with blown backlights that cause temporary Apple logo and then goes black. In this case, it looks like it's fixed. Look, we have a pin code screen, it's detecting the battery, 15%. So these are all good signs. So if you guys are doing iPad repairs with USB-C, make sure you guys get yourselves one of these. This USB-C meter helps with troubleshooting. If you get 15 volts, you know that the CD 3217 USB-C controller chip is working. You know the USB-C port is good. If you don't get 15 volts, also you got to make sure you have the right brick that supports 15 volts. So, 14.7, you round that up to 15. Also, you see the high current draw, like almost 2 amps. So this is seems to be a fully working iPad. Let me reassemble it fully and test it further. All right, so now that I have the digitizer and LCD all plugged in, I can now test that touch is fully working, and this seems to be a fully fixed iPad. Unfortunately, it wasn't a motherboard issue. It was just a simple battery problem. So hopefully you guys learned how to deal with dead batteries, how to measure them, how to check them, and how to jumpstart them. It's a really critical skill to have as a repair shop, to use a DC power supply to inject voltage into the battery and save the battery. So there you have it. If you guys enjoyed this video, make sure you guys are liking and subscribing. Comment down below what you guys learned from today's tutorial. And if you guys need a repair, send me a message. We do offer B2B pricing as well. So thanks everyone for watching. If you want to see more iPad repair videos, I'll post one right here, right below. And I'll see you guys in the next video.
All right. So yeah, it was that simple for him to simply inject some power into the battery to jumpstart it and get it to the point where it would charge again. And this is something that if you have the ability to do it, it really helps with a lot of different repairs. Whether it's just working on a completely dead phone that's come in and just sat there in a drawer somewhere and somebody's like, it won't power on, it won't charge. It's a very good place to start, especially if you're going to have to wait to order that particular battery because it's such an old model or a model that you don't have in stock. Even if it's a bad battery, as far as like it's not, it's going to need to be replaced, this is something you can do to at least get it to the point where the device will charge and it'll work again. So if you have any questions, leave them in the comments below. Definitely check out VCC Board Repairs. Got amazing content. If there's a channel that you'd like to recommend, please comment it down below. That wraps up today's video. Thanks a ton for watching. We'll see you in the next video.